All right, let's dive into the absolute heart of programming. We're going to talk about the building blocks that let you tell a computer not just what to do, but when and how to do it. We are talking about control flow and functions.
So you might think a computer program just reads your code like a book, right? One line after another, from top to bottom. And yeah, sometimes it does. But the real magic, the real power, happens when we break out of that straight line. What if our programs could think? What if they could make decisions and repeat actions all on their own? Well, that's exactly what we're going to get into.
I want you to think about these concepts as tools you're adding to your programming toolkit. And the very first tool we're going to grab, maybe the most important one, is the one that lets our code make choices. Let's call it the decision maker.
At the heart of making decisions in pretty much any programming language is the if statement. It's super simple, really. It just asks a true or false question. If the answer is true, a specific piece of code runs. If the answer is false, the computer just skips right over it. Simple as that.
Okay, check this out. A perfect simple example. We create a variable, x, and we set it to 42. Then the code gets to our if statement, and it asks the question, is x less than 0? Well, is 42 less than 0? Nope. So that condition is false. And because it's false, the computer completely ignores that indented print line. That line will only ever run if the condition is true.
But, life is usually more complicated than just one choice. What if you have a bunch of possibilities? That's where this powerful trio comes in. You always start with an if. If that first check is false, the program then looks for an elif, which is just a short way of saying else if, and it checks another condition. You can have a whole chain of these elifs. And then, at the very end, you can have an else. That's your catch-all. If nothing else was true, the else block is guaranteed to run.
All right, so now our code can make choices. That's huge. But what about those jobs that you need to do over and over and over again? I mean, you could copy and paste your code, but that gets messy really fast, and it's a terrible idea. We need a better tool for that. So let's grab the next tool for our kit, the repeater.
And our repeater tool is the for loop. Its job is incredibly useful. It takes a collection of things, like a list of names or even the letters in a word, and it performs some action on every single item in that collection, one by one, until it's done. This is the absolute key to automating repetitive work.
Let's break this down real quick. We've got a list here called words. The next line, for W in words, is our instruction. It's basically telling Python, hey, I want you to go through the words list. For the first item, cat, let's just call it W for a second and run the code underneath. Then go back and grab the next item, window, call that W, and run the code again. And boom, it prints out each word and its length, all automatically.
And believe me, this idea is everywhere. You use it every single day. When your music app plays the next song in your playlist, that's a loop. When you're scrolling through your social media feed, the app is just looping through a list of posts and showing them to you one after another. Loops run the modern world.
Okay, so take a look at this. On the left, you've got the if, elif, else structure we talked about. It works perfectly, but sometimes it can get a little long and clunky. Now look at the right. This is a newer tool called a match statement. See how it's a bit cleaner? You just give it one variable to look at, in this case status, and then you give it a clean list of cases to match against. It's often way easier to read. And that little underscore at the bottom, that's a wild card. It works just like else. It catches anything that didn't match the cases above it.
So, we can make decisions, we can repeat things, but as our programs get bigger, they can start to look like a giant, tangled mess. It gets hard to keep track of everything. To solve that problem, we need one last tool for today. We need the organizer.
And this amazing tool is the function. Think of a function as a mini program inside your program. It's a block of code that you package up, give a name, and design to do one very specific job. And here's the best part. You write it once, but you can run it 1,000 times from anywhere in your code just by calling its name. This is absolutely key to writing clean, professional code.
Now, this might seem a little complex, but it really just boils down to 4 pretty simple steps. First, you define it, using the keyword def. Second, you write the actual code inside it, the part that does the work. Third, and this is super important, you use the return keyword to send a result back. And finally, you just call the function by its name whenever you need to use it.
So here's what that looks like. That first line, def fib2n, is us creating our function. Inside, it's doing some work, building up a list. But look at that last line, return result. This is maybe the most important part.
This is the function saying, okay, I did my job and here's the answer I came up with. If you forget to return something, all that hard work just disappears.
And here's the second half of the puzzle. This line, f100 equals fib2 of 100, is where we actually use or call our function. The computer sees the name fib2, goes and finds it, runs all the code inside, and whatever value that function returns gets put right into our new variable f100. So when we go to print f100, what do we see? We see the list that the function built for us.
So let's just quickly recap the amazing new tools you now have in your programmer's toolkit. You've got if statements for making your code smart. You've got for loops to handle any repetitive job you can think of. You've got match statements as a really clean alternative for handling lots of choices. And you've got functions using def to keep everything neat, tidy, and reusable.
With these tools, you are no longer just writing a list of instructions that runs from top to bottom. You are in charge now. You are directing the traffic, you are creating the logic, you are truly in control of how your program behaves. So the only real question left is, what are you going to build with that power?